Hello friends, very good morning. Today our topic is conversion of a galvano into an ammeter or into a voltmeter, right? So what we have read, that was a suspended type galvanometer, but later on with the improvisation, instead of that mirror, a needle is used, a metal needle is used to detect the deflection directly, right? And that is called pivoted type. On that spring, instead of fixing a mirror, we fix a needle, right? A pointer, you could say, metal pointer, to detect the deflection. So far as the galvano is concerned, it is represented by a symbol capital Z, like this, right? And this shows the deflection. Actually, this G represents the resistance of a galvano. We will not write the galvanometer, simply saying galvano, right? Which is very low, hardly 15 to 20 ohm. First thing is that, right? Second thing, it simply detect the presence of electric current or electric field in the circuit, right? So it allows only a small amount of current to pass it through it. That is called IG. IG, we call it full scale deflection current. Means for that value, the galvano pointer will show a full deflection on the meter, right? So this is the basic of this one. If I say how much is the PD, so IG into VG will give you a very small value, VG, right? PD of the galvano. Now question arises, how to convert it into an ammeter and or into a voltmeter, right? So before going to that, we just talk about, let's talk about ammeter. An ammeter, a device used to measure the current, right? Represented by capital A, to measure the current in an electric circuit. Suppose this is the circuit I am representing. First thing is that how to apply a ammeter in an electric circuit, right? So what happened in combination system, we did talk about that. The resistance, or you could say the current, remains constant, or same, you could say, constant in series combination only. Series combination only. In parallel, it get distributed. The current remains constant in series combination. Means it is not going to vary, and we have to read about the current. So an ammeter is always applied in series. Make it a point. Ammeter is always applied in series, all right, because we have to read the current, so current must remain constant. Now a question is that what should be the resistance of an ammeter? So actually it is made up of all the system, so it will have a small resistance of its own. Let it denoted by RA, right? So if RA is the resistance of this ammeter, so what will happen? What will happen? I into RA will give you a small amount of potential difference, and this will be the PD used by the ammeter itself. So what will happen? What will be its impact? Naturally, the actual potential difference will reduce. So V actual will become this E applied minus VA. It simply means PD will reduce. If PD reduces, what will happen? Current will reduce. Means what? higher be the value of Ra, higher will be the potential difference used by the ammeter, right? So what we do, we will, in order to measure actual current, the Ra should be minimum, resistance of an ammeter should be minimum, so that a minimum PD is used by the ammeter, right? For an ideal ammeter, we did talk about that. For an ideal ammeter, what will happen? The resistance should be how much? 0. Remember this one, 0. For an ideal ammeter, the resistance should be 0. Means if we want to move towards the idealistic approach, the resistance of the ammeter should be 0 or should be minimum. Now, how to convert? Question was that. How to convert a galvano into an ammeter? I will take the first part. Galvano into ammeter, right? So no magic is going to happen. Remember, we will measure the current mathematically. I am not going to convert G into A, but I will use some method so that I could read the current flowing through the circuit. This is the symbol for galvano. G is its resistance. Here I am having, right? And it allows only a small amount of current, let it be Ig. But my aim is what? To use it as an ammeter, means I have to read the current. I is the current to be measured. So what will happen? If I allow this I to pass through the galvano, it will simply break down or may burn. So what we do, we apply a small value resistance in parallel combination with the galvano, represented by S and popularly known as shunt. This resistance is known as shunt. So what happens? Whatever current galvano wants, let it flow, and remaining current will pass through this shunt, I minus Ig. In that way, our galvano will remain intact, and by some mathematical calculation, we can measure the current flowing through the circuit. This is Ig, and the total current is I again, right? So this is a simple process how to convert. Just to convert a galvano into ammeter, what we are doing, we are applying a low value resistance known as shunts. Most of the time they do ask what is shunt. So be careful. In order to convert a galvano into an ammeter, a low value resistance is applied in parallel combination, parallel to the galvano, right? This low value resistance is known as shunt. Right? This is about shunt. So what is the main function of shunt? It allows the maximum current to pass through it, and galvano will have only that much current which it can accept, for which it gives you the full scale deflection. Now mathematically what will happen? As galvano G and S are in parallel, right? So what will happen? In parallel, the potential difference across both these two will remain same. So PD across Z will be equal to PD across S. So what is PD across Z? It is simply Ig into G. PD across S is I minus Ig into S. This is the key equation, main equation. Remember this one and everything is there. But I want to convert into ammeter, how to read the current. So I will just try to open it out. What happens? Ig into Z will be I into S minus Ig into S, right? So by that, what all I can have? Ig into Z plus Ig into S, I will just see on the side, equal to I into S. Ig into G plus S is equal to I into S. So I comes out to be what? G plus S divided by S into Ig, right? This will be the current which can be measured, right? What will be the value of shunt? इसको लिख देते हैं, is the current to be measured, right? Now for shunt, from this equation itself, S equal to Ig upon I minus Ig into G will give you the shunt resistance, ohm, right? This will give in terms of ampere. What will be the resultant resistance, total resistance? If I say total resistance is 1 upon R, 1 upon R will be 1 upon G plus 1 upon S. That will give you the total resistance, effective resistance of the circuit. So that's how we do it. No miracle is happening. We are not changing this G into A. We are simply making some mathematical adjustment and we can very easily read the current, right? Now some constant here which we are using here, though it is very clear, but even then I will mention it here, where Ig is, we call it full scale deflection current of the galvano, right? G, resistance of the galvano, S, shunt resistance, right? And so far as this I is concerned, I, current to be measured. Right? That is there, right? Just take one simple question on it and it will make everything crystal clear. It is one of the simplest topic, but most of the time it is there, right? Suppose I am having a galvano whose full deflection current is 50 milliampere, right? Its resistance is 20 ohm, and I want to measure a current I equal to 10 ampere, right? What should be the value of shunt? Yeah, how will you convert this galvano into an ammeter which could read 10 ampere current? For that, what we do, whenever there is a question, draw the diagram, circuit diagram first. Nothing is going to happen. This is Z, this is I, denoted by Ig, and this is I minus Ig. I is the current coming. In all questions, just draw this one, everything will be crystal clear. And this is the shunt value which we are using. And this is I. Again, I minus Ig. And Ig is coming from here. So, Kirchhoff law says it will remain I. Right? This is S. If I am not remembering, it is not with me, the equation, I can draw this diagram very easily. I can do it. This Ig into G is equal to this into this, right? Ig into Z is equal to I minus Ig into S. The PD is same, right? I want to calculate S. It will be Ig upon I minus Ig into Z, right? Up to this line, this approach line, all students can find it out. But problem lies with the biology one, how to calculate the value. Look, Ig is given 50 milliampere. Don't try to be over smart. Let it be come to the basic. 50 into 10 to the power minus 3 ampere, right? What should be the value? Right? It will be 0.05. Am I right? Right? Even if you are having problem, come to the basic. 5 by 1000. 0 is cancelled. 500 is 0.05 ampere. Make sure you calculate this value. Then S comes out to be 0.05 by current to be measured is 10. 10 minus 0.05 into Z is how much? 20. Right? So, if you just multiply it, 500, 5 into 20 is 100, it comes out to be 1 divided by 9.95, right? Ohm. Try to divide it, whatever you get, that will be the shunt value, right? Even you are having some problem with this one, come to the basic. I am again repeating this word. Don't try to be over smart, especially the bio branch. So what happened? 5, here it is 9 and it is 9.95. They do mistake such basic error here. While doing everything right, naturally they will not get the proper mark. So be careful. This is the value of S. If S is known, you can calculate total resistance, whatever you want. Whatever the simplest format. Right? This is how we convert galvano into an ammeter. Same way, how to convert a galvano into a voltmeter. Voltmeter. Right? What is the function of voltmeter? Now, how to convert a galvano into voltmeter? Voltmeter means to measure the potential difference. So, what we were having? Galvano can allow only a small amount of current to pass through it, and its own resistance is very small, G. Right? So, if I just check this value, Ig into Z will be a very small value. Small PD, right, which can be used to read the value of very small value. It is of no use. If I want to read the higher value, what to do? Right? So, how can I increase this value V? Question is that. If I want to calculate this high value V and I am having only Ig into Z, how to increase? How to improvise it? Ig we cannot vary. It is instrumental. It is a fixed value. Only variable is what? Capital G. And even in G, we can't change it. But what we all can do, I can simply increase the resistance by applying a high value resistance here. I apply high value resistance. There is no name for that. We simply name it high value resistance. Don't try to write down its shunt. It is not a shunt. Shunt is used only for ammeter. R is high value resistance, we call it. Right? So what will happen? If I apply high value resistance, whatever be the value of Ig, I can read a very high value V. Right? So, to convert a galvano into a voltmeter means to measure the high value of potential difference. What we do, a high value resistance, remember there is no name for it, high value resistance is applied in series combination with the galvano. right? This is high value resistance. So what will happen? It's very simple. It is more simpler than this one. V will be what? Ig into G plus R, right? Higher the value of R, higher will be the value of V, right? So whatever be the value of V, we can change R accordingly, right? This is simple form, right? Here, what is V? Where V is the potential difference or voltage to be measured, right? G again resistance of the galvanome, Ig full deflection current, and what is left? R is high value resistance, right? Now convert into numerical part. How to do this one? Suppose I am having a galvano which is allowing only 20 milliampere to pass through it. G is 25 ohm, right? V to be measured is 25 volt, right? How to measure V? So for that, this is in terms of voltmeter. So we will calculate R. So before doing anything, you have to draw the diagram, circuit diagram. Remember, this will make the picture very clear, right? What is clear here? It will be Ig into G plus R. Simple. V is 25, Ig is 20 milliampere. Again come to the basic. 20 into 10 to the power minus 3. G is 25. R is, we have to calculate, right? If you are having some problem, do it like this. 20 by 1000. Can you? That will make it a bit easier, right? It will make 50. Make it a cross multiplication if you are having problem. Remember, again I am repeating this one. 25 plus R will give you 25 into 50, right? So R will be, if you just multiply it, 25 0 25 from 25 here minus 25. So R comes out to be, oh, how much? 1225, 1225 ohm will be the required high value resistance to convert the galvano into voltmeter, right? Here, what should be the effective resistance? R effective, if you talk about, both are in series, G and R is in series, it will be G plus R. G we are having 25, here we got what, 1225, and it will be 1250. That's how we do it, right? In such numericals, sometimes they give some twist and turn. Suppose Ig is given 25 milliampere, G is given 15 ohm. How to convert? This galvano into first part 0 to 15 ampere ammeter, second part 0 to 30 voltmeter, right? So don't get confused by this value. What we have to do, we have to read the maximum value. If it could read 15, it can read all other values. Same way here, if it could read 30 volt, it will read all other value. In first part, what will happen? I will be 15 ampere, right? And likewise, you can calculate S here, do it by yourself. Since second part, V is what? You will take 30 volt, right? And R, you can calculate. That's how we do it. This is how we convert a galvano into a voltmeter or into an ammeter, right? Thank you and have a nice day, and keep on subscribing us so that we could help you a like this.